Here is 9-82 pre-calculus. I'm happy that somebody asked this question because, well, it's kind of nice because they're saying that they want you to solve for the indicated domain. And so it kind of shows the difference between when you're solving when x is in between 0 and 2 pi, or when you're solving like on letter C, you're solving the exact same thing, but it doesn't say that x is in between 0 and 2 pi, so you're going to have to write your answers differently. So the way that you start this problem is, this is the original problem right here. It says cosine x times 2 times sine of x plus root 2 equals 0. So if you're trying to solve it, you'll notice that these are factors. It's like this thing is multiplying against this thing. If something times another thing equals 0, then you can use what we call the zero product property. So you just kind of like when you're factoring quadratics or something. So there's no way that the answer to a multiplication problem can be 0 unless one or the other of the factors is 0. So you set the first factor equal to 0, and you set the second factor equal to 0. So this first factor, cosine x equals 0, all I have to do is go on my unit circle and find out where is cosine 0, like what angle measures makes cosine 0. So cosine is the x coordinate. Oh, here, let me do a autofocus on here. Did that help? It didn't really help. Okay, so cosine's the x coordinate. So I see that cosine is 0 at pi over 2 and at 3 pi over 2. Okay, so that's all. I don't have to keep going all the way around the unit circle, around and around and around, because they told me my domain is just between 0 and 2 pi. So there's 0, there's pi over 2, there's pi, there's 3 pi over 2, that's 2 pi. So I just have to record the answers that are on this unit circle for letter B. So those are the two places where x equals 0, where the cosine of x equals 0. And then for the second factor, I set it equal to 0, and I did a little algebra. So I subtracted root 2 on both sides, and then I divided both sides by 2. And then I got that sine of x equals negative root 2 over 2. Well, I know that happens at like the 45 degrees. Well, we're not in degrees, but that happens, the root 2 over 2's happen, I don't know, on these diagonals right here. So I just looked it up, sine. Where's sine negative? Well, sine is negative down in these two quadrants. So I know you can't see this, but you can look on your own unit circle. So sine of theta is root 2 over 2 at 5 pi over 4 and at 7 pi over 4. I know you can't see it, but look at your own unit circle. And that's it. That's the only places on the unit circle where sine of theta is negative root 2 over 2. Now the very next problem, letter C, if you'll notice, these are the exact same. You start with the exact same problem, but this one, the indicated domain, it doesn't give you an indicated domain. So that means I could go around and around and around the unit circle. So remember, when we solved this one, we said that x could be either pi over 2 or 3 pi over 2. That's where cosine x is 0. And let's check that. Cosine of x is 0 up here and down here. But if I don't indicate that x has to be in between 0 and 2 pi, I could go all the way around. That's 2 pi plus pi over 2. Well, let me do it in degrees because I can think better in degrees. That's 90 degrees, right? And then that would be 180. And then if I went all the way back down there, that would be, oh, I can't even think in degrees. That would be, there's 90, there's 180. 360 plus 90. I thought I could think in degrees. 450. So what I'm saying is that I can keep going around the circle more than once. You know, like if I went around the circle once, it'd be 360, but if I went around twice, it'd be 720, right? So I'm trying to account for the fact that I can keep going around and around the unit circle. It just so happens that the 90 degrees or pi over 2 and the 270 degrees, which is 3 pi over 2, it happens to be that those are pi away from each other. You know what I mean? Like they're like I'd have to move through pi degrees to get down to the next one. And then if I'm going to keep going back up for 1.5 rotations, I'm always adding pi. And then if I went around by pi more, I'd get back here and then plus pi. So that's why I'm writing it's pi over 2 plus pi times however many times I want to go around, or n. So I didn't have to write this answer down. That's what I think gets confusing. I didn't have to write the 3 pi over 2 because I can get there by just saying it's pi over 2 plus pi plus pi plus pi plus pi. So I don't have to write down. That kind of covers the 3 pi over 2. But on this one, you'll notice I'm supposed to get 5 pi over 4. Well, 5 pi over 4 is right here. The distance between 5 pi over 4 and 7 pi over 4, if you look right there, well, I mean, those aren't pi apart from each other. So you have to do these separately. You just go 5 pi over 4 plus 2 pi, which is one rotation, plus 2 pi. You can keep getting around there as many times as you like. And then so you have to do these separately because they're not separated by a perfect distance of pi like these two were. So basically, if they're not on the axes, you have to go plus 2 pi times n, or plus 2 pi times k if you use k. I think your book uses n. So I don't know if that unconfused you or made it worse, but the only difference between these answers and these answers is that the domain on here was restricted to just once around the unit circle. And here the domain, you can go around and around, so you just have to put that n on there.